on. Yeah, here we go. So, okay, FD device is going on, so hopefully it works. But hi, my name is Heath, and I am 1/3 of the members of this project that we've entitled Consuming. Okay, sorry. You guys can just deal with my voice, sorry. But anyways, I am 1/3 of the members of this presentation called Consuming Chemicals with Brianna and Noah. And the objective of our presentation is to kind of introduce to you guys the chemical compounds that we've been focusing on in our semester, and what you guys, how you guys are actually consuming them. So I'll give you guys about 30 seconds because I want to respect you guys' time. And let's practice some balancing of chemical equations that we've seen this semester. And they're going to kind of tie into what I'm going to present to you guys today. So kind of see if you guys can balance it. And then in about 30 seconds or so, I'll actually reveal the answers, as well as what this compound is. Okay. Alrighty. I'm just going to keep going because I know it's like a little awkward with silence. But you guys should have gotten 2, 2, and 3. And this substance is potassium bromate, which is, I think that was pretty good practice for the final next week. But I think it's also a great segue into potassium bromate itself and what where it's found. You'll find the substance typically in buns. And the whole purpose of it is because, you know, potassium's a pretty, what's the word for it? I don't want to say explosive element, but it's a pretty reactive one. And the purpose of it is to help the flour rise. And it's mixed with a bunch of other chemicals and substances. And what's really interesting about this in particular is that when we're talking about burger buns, it's actually banned in a lot of countries. It's banned in Canada, it's banned in most of Europe, it's banned in the Soviet Union, pretty sure. But America, for some reason, which is really interesting to me, we don't have a ban on it, but rather we just have the FDA giving us regulations and telling us, hey, you have to tell your people who are consuming these products that there is potassium bromate in it. And because Americans are pretty ignorant, we don't really care, and we'll consume it regardless. But we're just told don't consume too much of it. But we don't have a national ban on it, which is really interesting. Let's continue with more practice. Let's actually balance some charges now. So if I could have you guys take about 20 seconds or so to balance calcium and sulfate. That was like 10 seconds, but I'm just going to continue. And so by using the crisscross method that we've learned by putting 2 over here and 2 over here, the actually balance out to be neutral, 0 charge, or 0 subscript, I guess I should say, sorry, not charge. And we end up getting CaSO4, which is calcium sulfate, which is really interesting. Calcium sulfate is found in a lot of pastries in particular. And, you know, all our lives we're told, consume a lot of calcium, consume a lot of calcium. And calcium sulfate in particular is not as dangerous, I guess you could say, so to speak, as it is with potassium bromate. But calcium sulfate is really dangerous in so much as there are connections between a lot of medical conditions, including and most notably constipation. So just as we say with potassium bromate, we don't have national policy or regulation that tells us, hey, you're not allowed to include calcium sulfate in your meals and desserts and treats, et cetera, et cetera. But we do have advisories from the Food and Drug Administration that tells us, hey, just tell your people don't consume too much of it. Whereas other countries have an entire, law against consuming too much. So yeah, constipation is not a fun thing to experience. Now let's identify some elements. So obviously this is fluorine. I hope that's pretty obvious to everyone. And fluorine actually has a huge connection with McDonald's products, specifically Big Macs and Chicken McNuggets. So fluorine is a substance which is used in a lot of food wrappers. So boxes, Big Mac boxes, Wendy's bags, Whopper wrappers, et cetera, et cetera. And this may not seem like a big deal, but it is because this substance in particular does not break down easily in the environment, let alone in your body, because your food is interacting with it. And why this also becomes a problem is because it's not breaking down, you have an increased likelihood in infertility issues, an increased increased risk of cancer, weakened immune systems, and low birth rates, which is very unfortunate. I personally have never had a Big Mac, but I am craving one right now. And so I think that it'd only be appropriate to kind of watch a video on Big Macs in particular, maybe a short, like 2-minute clip or so, and find out what's in a Big Mac. And let's see if I actually really want to go out of my way to consume it, or if the risks are too.
This is a Big Mac. And this is everything.
Can you guys hear it? Or I hope you guys can.
Yes, we can see.
You can hear it? Okay. Let's fast forward. I want you guys to be able to actually like understand what I'm saying and like not have it be a bunch of just like me talking and you guys like going in one ear out the other. So I'm going to try and look for chemical compounds that we actually have studied this semester to make it a little more exciting for you guys.
Yeah. Now, some of these chemicals can actually be quite dangerous. Calcium chloride can lead to burns in the mouth and throat, excess thirst, vomiting, stomach pain, and low blood pressure. So I'm going to put some gloves on. Now, despite its potential dangers, calcium chloride is actually a great way to improve the saltiness in food without increasing the sodium content. Alum is one that we've mentioned before, and apparently this improves the crunchiness of pickles. Potassium sorbate, as it says on the label, is a mold inhibitor, which will give the pickles a longer shelf life. And finally, we have polysorbate 80. Now, this is an emulsifier which will thicken liquids. However, it is also the one that gives mice cancer. It's forming like, can you see this? It's forming like crystals, like stalactites.
Oh, it's like solidifying or something right now. What is happening? Get away from it. I feel like I'm watching someone making an explosive. The way he's shaking it, it's like, oh, it's gonna explode. Looks like this is the first time Harry's ever cut a cucumber.
Still quite lumpy.
Okay.
The Big Mac bun.
All right, perfect. So actually just that little portion, that's just talking about a pickle. Fun fact, that's not the entire Big Mac sandwich. As you can see, it's a 17-minute video. I will put the link in it because I was very interested when I was watching it. And I'm sure you guys, if you're interested in what I'm talking about, and you guys might be interested in what this video must have to offer as well. But now I'm going to pass on the torch to Brianna to give her a portion. Oh, no, I won't.
This is a...
Anyways, I'm Brianna, and just a little heads up, if I glitch out or anything, my Wi-Fi is a little bit.
She gone.
Deal with decomposition and spoilage, and overall improve the quality and stability of food. And the next slide. Okay, and I think I'm glitching. We'll see. But we are able to salt, cook, dry, dehydrate, can, use spices, pickling, and ferment all types of food. And like this just improves food. And like there's even more ways you can like improve or like more food. Like you could use liquid nitrogen and like freeze the food somehow and everything. And yeah, next slide. And so cooking is basically chemistry. And some everyday examples, which we're going to take the example of the burger. So we have the browning of food, which is caused from when sugars combine with proteins in the Maillard reaction. I think that's how you pronounce it. So basically to get that nice sear on your mac and cheese, and you get that nice little crispy browning of the cheese on top, you know what I mean? And then baked goods, which is like the buns. And I think I'm glitching again, but we'll see. And basically acid plus base reaction, which results in water, carbon dioxide gas, leavening, which aerates the dough and batter to make it fluffy. And as Heath talked about, we saw the little bun and cut the cheese, and that's basically milk plus rennet, which is an enzyme, plus a lactic acid bacteria mixed together. And then that rennet enzyme breaks down the protein in the milk to separate the substance into water and curds. And those curds are then salted and molded to make cheese. And they're normally in those like round wheels of cheese, or those rectangle ones, which we slice up and put into our burger. And then next slide. And now we're going to take a closer look into that chemical reaction where basically the dough is like being aerated through yeast. And yeah, play. And yeah, and as we saw it rise, and it had that little marker from the start all the way to almost reaching the top of the jar. And yeah, and then next slide. Oh. Okay, and now since we looked closer at some buns, now we're gonna look into pickling, specifically pickles. And personally, I am not a fan of pickles, but I do enjoy giving them to my friends because they get so happy when I give them, when I don't want them and I give it to them. They always have a smile on their face and they always fight over them. So yeah. And then so we're gonna start. So pickling is the preservation of foods in salt brine or vinegar. And that's pretty much what pickling is. And so we're gonna go through the little stages and jars of pickling. So we start off with a cucumber and we put it into a brine, which is gonna be with salt and acetic acid, which is vinegar, with some spices and herbs, so I give it that flavor. You could also add that one chemical that was shown in the video, which helps it with its crunch. And then we go into this fermentation period, which is inside the jar, where glucose sugar turns into a lactic acid and then it goes from that, which is basically the chemical equation for it. And then we have the lactic acid takes away all the bad stuff that make it spoil, and the acidity goes up and the pH levels are lower. And now we have pickles that are ready to eat and sliced up and put in my burger, and I could give it to my friends. And yeah, and now I'm gonna give it to Noah.
Hello class, my name is Noah Morano, and this section of the presentation will be about caffeine and how it pertains to chemistry. Objectively speaking, caffeine is the world's most addictive stimulant. Personally, I started consuming it when I was like 4-ish, and I'm pretty sure at least 90% of us here consume some form of it on a weekly basis. With that being said, let's get started. So here's just some basic information of caffeine. Its scientific name is 1,3,7-trimethylene purine 2,6-dione. Small mass is 194.19 grams per mole. Its density is 1.23 grams per centimeter cubed. Its melting point can vary from 235 to 238 degrees Celsius. In nature, caffeine occurs in things such as tea leaves and coffee beans. Scientifically speaking, it is an alkaloid, which is an organic compound that has at least one nitrogen atom. Common alkaloids that you may have heard of are morphine and nicotine. This pretty much explains why it is so addictive. Next slide, please. Here's the chemical structure of caffeine. As we can see from the chemical equation, it is made up of 8 carbon atoms, 10 hydrogen atoms, 4 nitrogen atoms, and 2 oxygen atoms. And from this, you'll learn about this in the later slides, but it's very similar to the chemical structure of it, or molecular structure of it, is similar to adenosine. So the most common form of caffeine is coffee. First and foremost, as we learned in earlier chapters, there are chemical and physical changes. Because a new substance is formed when hot water and grinded coffee beans mix, brewing liquid coffee is a chemical change. To add on to this, there is an exothermic reaction because heat is being released. Generally speaking, coffee has a naturally bitter taste. This is because of the volatility of the thousands of compounds found in your average coffee cup. When brewed, coffee has a blackish brown color as a result of the Maillard reaction mentioned previously by Brianna. Next slide, please. And here is the Maillard reaction put into action. All right. So caffeine gives us energy, but why is this the case? So naturally, our brain produces a chemical known as adenosine, which binds to things like adenosine receptors, causing us to experience fatigue and drowsiness. It's pretty much just the way we are built. So as we can see from the picture over there, caffeine has a similar molecular structure to adenosine, and as such, our nerve cells see caffeine as adenosine, and as a result, caffeine binds to the adenosine receptors in our brain. The result is the inverse effect that adenosine has on our brain. That being, it gives us energy. Another effect that caffeine has is increased neuron firing, which is basically the communication between neurons in our brain. Our pituitary gland senses this, and as a result, they release hormones that produce adrenaline, the fight or flight hormone. And also, caffeine increases dopamine levels, a neurotransmitter related to pleasure. Be warned though, as good as it may seem, caffeine can cause a cycle of problems. The recommended amount of caffeine is 400 milligrams per day. Essentially, caffeine is a drug, and our bodies are not meant to feel energetic and jumpy all day. So, in short, use caffeine wisely. And here's just a small little video. Go ahead.
Millions of Americans use caffeinated beverages every day as a pick-me-up. It is, after all, the world's most popular drug, and with new caffeine-infused products like energy drinks, gum, and even beef jerky hitting the shelves, our love affair with caffeine shows absolutely no signs of slowing down. Caffeine is an interesting drug because when it enters the body, it breaks up into 3 different yet very similar molecules. When metabolized in the liver, enzymes chisel off one of 3 methyl groups to form these 3 metabolites with 3 different effects on your body: theobromine, paraxanthine, and theophylline. While in the brain, this caffeine party crashes adenosine receptors, blocking the normal guest, adenosine, from doing its job. Adenosine is responsible for slowing down nerve activity in our brains, giving us the cue to calm down and take a nap. Also, adenosine is responsible for regulating neurotransmitters in the brain, such as dopamine. As you can see, adenosine is also quite similar to caffeine in structure, which is why caffeine binds so easily to the adenosine protein receptors. Once connected, caffeine increases the activity of neurotransmitters like dopamine, ultimately leading to heightened brain activity. Then the three metabolites perform their own specific functions. Theobromine increases oxygen and nutrient flow to the brain. Paraxanthin enhances your body's athletic performance by increasing the rate of fat breakdown to fuel muscle activity. Theophylline increases your heart rate and reinforces your ability to concentrate. And although these effects come together to produce a state of wakefulness, too much caffeine can turn sour pretty quick. At higher doses, caffeine is known to cause jitters, anxiety, and just general all-around discomfort. For this reason, scientists have found that 400 milligrams is the safest average dose of caffeine for adults. To put that into perspective, that would be around 3 8-ounce cups of coffee, 5 8-ounce Red Bulls, or a whopping 8 cups of black tea. And on a side note, scientists have also found that caffeine becomes toxic around 10 grams, which works out to be about 75 cups of coffee or 180 cups of black tea. However, the lethal limit does vary widely from person to person. Hey, thanks for watching, folks. Stay tuned next week. We've got more science coming your way that can...
Okay. Yeah, so that is the end of our presentation. Does anyone have any questions? You guys can just say it out loud or we can message you. But we hope that you enjoyed. We hope it was engaging and that you guys took something from it and make connections from what we've focused on this semester to how that's applied to your everyday life. Yeah, thank you. If I can even figure out how to get up.